Hey everybody, how's it going? This is Sophia with Bluegrass Green Source, and today behind me we are at Can Run Watershed in our very own Lexington, Kentucky. Now we are going to be doing a few tests that it's going to assess the health of our stream. We're going to be testing dissolved oxygen, nitrates, and pH. Dissolved oxygen is the amount of gaseous O2 that's dissolved in water. And it gets in our streams through maybe decomposed organic materials, groundwater runoff, and how fast your stream is flowing. Nitrates are a major protein component found in all living cells. So if we have excess plant growth, that plant growth can take in the nitrates. Those nitrates from the plants will cause them to soak up the extra oxygen, and it'll take it away from your aquatic life, so you won't have as much diversity. The last thing that we're testing for is pH in our water, which is going to test the hydrogen concentration of our water so we can see how basic or acidic it is. And this is important because if it's below 5, then it's going to be too acidic for human or aquatic life. If it's above 9, then that means it's going to decompose organic matter. So we are going to be looking for something right in the middle. Okay friends, so the first thing that we're going to test is pH. Now I just got a sample out of our stream right here, and what we're going to do is we're going to take our test tube and we're going to try our best and fill it up exactly to our line. Oh, our line right here. Just pour a little out if you get too much, and it's almost perfect. Now, we're going to take our solution, which is our wide range indicator, and our magic number is 8. So we're not going to do any more, we're not going to do any less. 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. Now my friend Miss Kara always says cap my chemicals, so I can't forget. We take our lid, press it on, and you want to slowly invert it. You don't have to mix it up like you're making Kool-Aid. Just put it upside up and down. Now we're going to take our indicator right here and we're going to slide it right in so we can see what number of pH it might match up with the best. Okay everyone, as you can see with our sample right here that we have slid in, we are going to look on our indicator and see what pH color it might be the closest to. And as we're looking at it, it looks like it's around 8, so that's not too bad. Okay, so for our nitrates, we take our water sample that we just got, fill it up to 5 milliliters. There we go. And now what we are going to be doing is we're going to be adding our nitrate 1 and 2 tablets, but we're going to be doing this individually. So we take 1 tablet of nitrate 1, and then you want to cap this one and make sure that you shake it up so it breaks up. So the way that we were able to mix things up earlier, it was a little softer. This one, you can shake it a little more to make sure that the tablet breaks up. And that's about what it should look like. So we're going to take the second one, nitrate number 2 tablet, uncap our mixture, and pop it in. Now this one's a little bit harder to break up, so we're going to take a second and let it break up. Okay, now it's time to take a look at our nitrate results. So after we've mixed in our tablets, this is the final color that it looks like. We're going to slide it in and then see which color that it might match up with the most. After looking at it for some time, I think it might fall between 2 and 4. Don't you think? So let's say it's about a 3. 3 on our scale will show that it is very close to good. So it in fact does have the right amount of vegetation around it. Okay, so for the first thing for our dissolved oxygen test is we want to get a water bottle sample of the water of our stream. And the most important part is when you put it underwater, you completely submerge it and also cap it underneath. You don't want to let any oxygen get under there. So it's going to be just like this. Make sure all the bubbles get out. Once you know all of them are out, it can be kind of tricky, but once you pull it out, it should look like this. When you turn it upside down, there should be no air bubbles that come to the top or bottom, and that's how you know you've done it correctly. Okay, so now we're gonna start testing for our dissolved oxygen. We are going to uncap our sample. We're gonna take our manganese sulfate solution, and our magic number is 8 drops. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now the second substance that we're going to be adding in is alkaline potassium iodide azide. 8 drops again. 1, 2, 3, 4, 5, 6, 7, 8. It's okay if it overflows because that happens a lot. You just want to make sure that you cap it. Some of it will leak out. And what you are seeing right now in the bottle here, inverted, is the flocculation in the water. So all of the chemicals in here, they are making sure that the particles in the water are coming together so that we can see it. And now after I do this a few times, we're gonna let it sit for 5 minutes and let all the flocculation settle. All right, everyone, so we have let our solution settle, and miraculously, this is exactly how it should look. It should look extremely clear on top and all of your flocculation on bottom. Now, after you've waited that period of time, you want to take your sulfuric acid and do the exact same thing that you did in the last steps. You want to add 8 drops. Our magic number, remember? 8 drops. All right, so 1, 2, 3, 4, 5, 6, 7, 8. Awesome. We are going to cap it again, and you can see our particles already starting to separate. Now we're going to mix it, and let's just keep mixing that for a little bit. Okay. Now, if you can see, our water is about an amber color right now, and that's good, and it has these little darker particles floating through it. You want less of those, but these look like they're okay for right now. Now, you want to take your other sample bottle and fill it up with this solution, 20 milliliters. Excellent. The next thing that you want to do is you want to get your sodium thiosulfate, and you want to get your titrator. And you know how nurses fill this up? You want to fill it up the same way. So put it inside, flip it upside down, make sure the connection is sealed, and fill it all the way up. There we go, looks good. Now, the amount of there are numbers on the side of this right here, so where you can clearly indicate them. You might have to fill it up again depending on your stream, but usually it takes at least a full one of these. You want to insert it in here and then just gradually pour some in and swirl. And you want to do this until your water sample is almost clear. Excellent. That's the pale color that we want to see. Okay, so now it's at the pale color that we need. The next thing that we are going to add are 8 drops of our starch indicator solution. So we're going to uncap it, and it's actually going to turn it like a purpley indigo color. So 1, 2, 3, 4, 5, 6, 7. This one's giving me some grief, isn't it? Okay. Now you want to cap it again and swirl it around. And it should look like diluted Kool-Aid. Now, do you remember the sodium thiosulfate that we used? In our mechanism here, we had our scale of 0 to 10. The first time I used it, it stopped here at the 8, but it looks like that we're gonna need some more. Our next step is that you wanna keep adding this and swirling it in until your solution is clear. So let me add the rest of this in and swirl it. And there we go. Okay, do you remember how we just took our sample here and turned it from pale yellow to purple? That is because we added the solution that was in this inside. And as you noticed and you saw the close-up earlier, it goes from 0 to 10. Sometimes you only need a few drops of this solution, and that is the pour range. When we were finished with our experiment, we used the entire amount of liquid. So we actually fell at 10. So it looks like our range is perfect. All right, everybody. Well, thanks for coming with me today to assess our streams. It can be surprising, but ours looks healthy today. So I hope you're able to get out there and assess your own.